Now, since we're working with strings, one of the things we'd like to be able to do is enter the string in at the keyboard. I had shown you last time a little function for reading a single character. Well, in configure usart.c, we've given you a, a string, a function that basically uses that read usart a number of times to read a bunch of characters from the string, from the keyboard input. So let's go back to strings example. And what I've done here is I've got a little while loop. And so this is an infinite while loop until I get out of it. And to get out of it, I actually have to type exit, E-X-I-T here. But in between, it just gives me a message and asks me to enter any kind of text that I want, and it puts it in blank. So let's see what that actually does here. Okay, so we want to enter 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can see it, once I tried to enter the 11th number, it ignored me. I had finished the 10 that I'd asked for. If I want to do something smaller, I hit enter. I also can backspace to get what I want. So this is perfect for entering any sort of strings. Again, the string that I'm putting the characters in has to be long enough. You can have all sorts of weird problems that we won't go into if the string is not as long as the amount of characters you're trying to put in it. Let me type exit here, and then look at what comes next. So we can get strings from the keyboard, and that's great, but sometimes we want to manipulate those strings. We could say convert them all to uppercase or lowercase if we wanted. But one of the big things we want to do is take text and convert it to numbers. And those are functions that are part of the so-called standard library of C. Let's have a look at some of those functions. This function right here takes a string and converts it into a 16-bit integer, or integers. Or we can convert to a double or float, or to a long, which is a large integer, 4 bits instead of 2 bits. 2 bytes, 4 bytes instead of 2 bytes of information. So these guys are down here, and they repeat. They're in do loops as well. So let's have a look at those. So here, we're trying to get signed integers. Okay, it's going to use the A to I function, which is found in the standard library, which is listed in the appendix. So if I type an integer, perfect. If I type something that's not an integer, it'll round it down. Right? What about if I use numeric stuff? It returns a 0. That's actually a problem, right? If I had entered 0, it also returns 0. So zeros are a bit problematic here. Okay. And if I enter a number that's too big, it's outside the bounds of the memory space, and you'll get some weird numbers, something called rollover that we'll talk about later. If you want to deal with longer numbers than about 32,700, then you use a long integer. We won't really need to talk about them much, but 100,000 is too big to be an integer, and you can see it handles quite fine. You can go up to about 2 billion with a long integer as opposed to the 32,000 that we had before. You can be small if you want, right? We can do what we want. All right, so integers, long integers. The next type would be floating point or decimal numbers. I forgot to take exit. Let's get out of here. Okay, and this uses the function a to f. So if I have 12.345, it gives me 12.345. Any sorts of decimals. If you want to use exponentials like 12.5 E6, right, it'll try and fill them in. There's lots of formatting that we'll learn later to print these things out the way that we want. So let's quit that for now.